Good evening, I am Mr. Ish. We are continuing with these videos, preparation videos, material videos, all with regards to maths. The video today is on solving trigonometric equations part 2 because we've already done a part 1 previously. We have to look at this equation here and find all the solutions of x within the domain 0 to 2 pi, including 0 but not including 2 pi. How do you go about this? When you see something like this, you have to bring everything into a similar function or a single function. Here you have two different functions, sine and cosine. If you think about the Pythagorean trigonometric identity, sine square x or sine square theta plus cosine square x or cosine square theta is equal to 1, you can utilize this to convert everything into a cosine function. Sine square x is equal to 1 minus cosine square x, and this right here can fit right in here, and that would be the ticket you need to solve this out. You have 2 into 1 minus cosine square x plus 3 cosine x is equal to 3. Open this up, you have 2 minus 2 cosine square x plus 3 cosine x is equal to 3. Make this into a quadratic equation. Maybe we don't need to take 3 on the other side. You have minus 2 cosine square x plus 3 cosine x minus 1 is equal to 0. Hit everything with a minus and flip the signs around. 2 cosine square x minus 3 cosine x plus 1 is equal to 0. You can easily factor this out and it should not be hard. 2 cosine x, you have a cosine x over here, that it'll be a minus 1, you get a plus 1 and you get a minus 3 cosine x. So this factors over here are good. Individually solve these out for equaling 0. 2 cosine x minus 1 is equal to 0, and we have cosine x minus 1 is equal to 0. Solve out for x. Cosine x is equal to 1 over 2. Cosine x is equal to 1, x is equal to inverse cosine of 1 over 2. What are the angles for which if you were to cosine them you get a positive 1 over 2? Cosine is positive in the first quadrant and it's positive in the fourth quadrant. So there must be the 60-degree angles in the first and the fourth quadrant, and that would be 60, which is pi over 3, and 300, which is 5 pi over 3. And what angle for which if you do the cosine you get a 1, and that must be 0 and 2 pi. But 2 pi is out of the domain over here, so you don't go for that. Your answers are 60, 300 and 0. Technically you would plug these values right in here and the right side should equal the left side, and then you would verify that these answers are indeed good. Now the second question for this video is right here. You have to find the solutions of x such that they fall within the domain 0 and 2 pi but not including 2 pi. The equation is 2 cosine 3x minus 1 equals 0. Technically this right here is referring to the period of your cosine function. Remember, cosine and sine normally have a period of 2 pi, 360 degrees. That is, a full wave is 360 degrees long. But this right here is going to be slightly different because the period is always 2 pi over b. b is a coefficient of x. Here's my b. So the period of this wave will be 2 pi over 3. So rather than the normal 360 degree wave, you have a 120 degree wave. So you have a slightly condensed wave. Anyhow, that's besides the point over here. Let's actually get into the question. It's just algebra here disguised in trigonometry. 2 cosine 3x is equal to 1. Cosine 3x is equal to 1 over 2. Now take the cosine on the other side and maintain the 3x over here. 3x is equal to inverse cosine. Inverse cosine of 1 over 2. Again, what angles, if you were to cosine them, you get a half, a positive half. Cosine is again positive in the first and the fourth quadrant. 3x is equal to 60, which is pi over 3, and 3x is equal to 300, which is 5 pi over 3. Remember, you're using this right here, your reference horizontal, your 0 and your 2 pi reference horizontal to get this. You're going 60 up and you're going 60 down. That's a positive 60 and that's a 300. And that's what these are. 3x is equal to pi over 3 and 5 pi over 3. Therefore, x is equal to pi over 9 and 5 pi over 9. And these are your solutions which fall within this domain. And you can calculate what these are. 180 divided by 9, that's a 20 degrees, and multiply that by 5, that's 100 degrees. So seemingly we have two good solutions there, 20 and 100. If you were to plug 20 in here and 100 in here in place of x, you would easily show that 0 is equal to 0, and these two solutions would be good. But if you want to be a little bit more sophisticated in terms of your answers and the whole presentation here, and you think back to what I said over here with regards to the period, I said the period over here was 2 pi over 3, which is equal to 120 degrees. If you want to present all the relevant solutions which is within the domain 0 to 360, and you know each wave here is now 120 degrees, which means the next viable solution would be 120 degrees away, and that would technically be 140, and you can say that's 7 pi over 9. And this other solution right here would be another 120 degrees away from here, and that would be 220 degrees, and you know that would be 11 pi over 9. What this tells you that in addition to this two seemingly good solutions you're having, there are two more you can generate: 140 degrees, 7 pi over 9, and 220 degrees, which is 11 pi over 9. So you don't just have two solutions here, you technically have four solutions, and they all, these numbers, and you can see clearly 20, 100, 140, 220, they all fall within this domain of 0 to 360, and that right there is why we had this little setup over here with regards to the period, because the period can be utilized to your advantage to find additional solutions which are not seemingly clear, but they are actually present in there. So these two solutions here, 20 and 100, are good solutions, but the best solutions are all four of these included. And with that, let's end this video. Stay tuned to my videos, and I appreciate you all watching them. Thank you for watching. Have a nice day.